Yum, yum!
Okay, welcome everyone. So, you might hear me correctly, I think. It should be okay. Okay, so we are opening again this scene. So one thing I was looking at with this scene is, I could create all those parts just procedurally, and after that export them as an FBX and batch UVing all of them. So what we've seen before is that many stuff is repetitive on some axes or on both axes, like those. And electronic parts are really like this. You have a base and you have different variation, and that's typically a good example of what you can do with procedural modeling. So all of those were not done like this with procedural tools. So you have some limitation and you cannot change them easily and change the amount of pins and stuff like this. So we will continue what we've done before on the little chipset here. So as you can see, by my experience, I know that when you are putting a chip into a support like this here, you have to take care about some markers. Here you have a marker that is just a carved space in here on the side, and all of them have this here, here, here. So it helps be sure that the chipset is correctly oriented. Okay, as it's long, there are just two ways to put it inside. So we will close this scene and open back the precedent scene we've worked on. So it was this. Yeah, that's right. So we were at this point, and we may need to create something that can help us to create the base shape of this. And also, not just creating the case. Oh, sorry, I'm missing some stuff on my keyboard. I should switch. Okay, that's fine. Switch again. I'm working with both. The AZERTY keyboard, the French one. Because yes, that's probably a must to use any software, I mean DCC app, with a keyboard that is not in the correct language. Every software were used to be created with people that were mostly English, or using English, so it's important to have a good keyboard for that. So I will switch back to the English one, and now I have correctly my key binding. Okay, W. So we have this. I should check that. Okay, so we have a mesh that have a specific size, and from that size we will duplicate the pin along this size. So basically, I will open back the assembly we've made. So we were working on this case, and this case have a specific size that drives this cube here. So the cube here we're duplicating with the replicator the pins on the side, and the subdivision of it could define the number of those pins. So what we should do here probably is I will switch maybe to the advanced mesh up panel. It should be better to see everything. And I have more space. I will switch this up. Okay, so we've discovered that you have plenty of solution for making this kind of stuff. So you can duplicate a square here, or just creating a flat square. In my case, I was deleting the, where is that? We have a cube, and the cube is not a cube. This is flat on Z. So on the Z, you have just a plane, okay, in two dimension. So we can probably to duplicate those here and there, instead of merging things, I mean merging the replicator into a new mesh and do the mirror, we can probably do the mirror directly on the cube, on the source of the particles. So if I go there and connect the geometry here, you see it duplicates the polygons, but you see there's some misorientation. So this is something you should check from time to time, if something is able to be used this way or not. Sometimes it didn't work. So yeah, I can do this way, or probably I can do a different way. So if I do the mirror, you see that the point order is changing, so everything is messed up. So we will left this on the side as the mirror into the composite. Okay, we will call this one composite. I will just double click here and reconnect it again. So if you want to create some assembly aliases at the end, what is important is to create a deform folder. So even if you create an assembly, the assembly can be loaded, but you will lose the order of the merge mesh, where the merge mesh at the first or at the second, or you will mess up the order. So sans Paris. Okay, anyway, so we will add a deformer. Okay, so I just press tab, and with the team person pop-up, I can directly find the deformer this way and reconnect here. So the first time you connect it, of course you are just moving the deform folder at the top, so only this one is used. Okay, the merge mesh. Everything that is behind will be ignored. Okay, so I reconnect this one here, and now you see we have a merge mesh here and the mirror here inside a deform folder. So this way you will not lose the order. That's important. If you want to use later this setup into another assembly, it's important to save and preserve this. So we were using this prototype. Yeah, we've created a vertex and duplicated that vertex, and where is that? Should show it. Okay, so we were duplicating those like this. It could be okay, but yeah, so that was the twice solution we've prepared. So this one is not used actually. I will move those a bit up. We just ignore the rest. So I will get back everything, the replicator and the case. So just hiding the rest and getting this. So here we have a specific size, okay? we have in the display, I will show the dimension. We have a dimension here. So on the x-axis, we have this amount. So we should imagine that we will duplicate those, the cube, or I mean subdivide it in relation with the size of it. So what you can do is do in two different ways. You can change the okay, we have the segments on the x that we were driven here. So if I go to the assembly and change this count, I can add more. As you can see, the relation between the count and the size is there. So we should probably have a control on the length of it. So we will create a new user channel with distance, and this will be the length. Okay, this way, the length of the chipsets. So as we are working with millimeters, I've set up my Modo configuration to meter, so I will use this amount. Okay, the default value will be 2 centimeters. Okay, so I pressed undefined 0.00, so 20 meters, 0.02. So 2 millimeters, it's just 2 centimeters. That should be enough for the test. And so the cube here now have a specific size, but the size is defined by the case of the original one. So what we will do is create a new, should change those random music. Okay, that's a bit strange. I should create a playlist. Okay, so I created a new mesh that I will drag here, and we will create a new cube from this to have a total control over the size of the chipset. So I will call my Mesh Fusion cube. Okay, so now we have a cube connected, and of course we will drive the size of it with the length here, but also we need to define the width. So it will be 0.5. We'll do this. Of course the minimum is 0. I didn't do this here, but it's not a problem. So here the cube will be the length on the X, and on the Z it will be the width, right? Okay, so that's working, but we should also define the width by probably half the width for the height. So we'll use a divide or multiply, just multiply, that should be better to have some percentage control after. So 0.5 in that case, and we will drag this later on. Okay, so now we have this. Oh, the size is a bit too big. Okay, multiply by. Okay, so we have 0, 0. We'll do the divide. Same. Okay, 0.25. I've connected to the length. Okay, so that's why it was not good. 0.5. Go back. Okay, so we have this. Now the cube is centered. Okay, the center is there, and the cube itself is centered in relation to this center. So we should use the position on the y-axis to be a bit bigger, to be a bit higher. So we'll use the size y divided by 2. So we'll add another one, a math node, use the size y to connect to the position y, and divide by 2. So now we have a cube correctly at the correct position. So after that, we will probably add a control, an offset. Okay, so we have this here. We'll probably move this out of that. And connect the mesh from the mesh info to the new cube. Okay, so now we are adding this maybe. And we have a basic chipset, right? So now if I define how I will process, the better way is probably to use the clone tool, the clone mashup, instead of using the segment on the X of this cube. So I will remove this, define a size for the pin. Okay, so here we have a plane that is 20 millimeters by 2.5. It's too big. Okay. So maybe the size will not be controlled by this. So here we should just connect to the bounding box on the Z. Should control the position on the Z. Okay, right. So now we have a plane that should be maybe okay, we will just use 1 millimeter by 1 millimeter. Okay, 1 millimeter. So now we have just a patch that is orienting and duplicating the pin along. So this way I can create a clone or an array, but what we will do, it's important to look at the solution we can use, because the array we can repeat this, but it's just on one side, on the 4 different sides of the chipset. But okay, we will use the clone. Drag and drop this here, and we have the linear generator here. So what is interesting with the linear generator is the between, because this way we can switch between the between solution and the size of the clone. Okay, the spacing here. So here we have a cube, just a plane that is 1 millimeters width with the width. So we probably have to make this bigger. We'll do 2 millimeters by 2 millimeters. Okay, so we have a bigger one, maybe 2.5. Should be 2.5. Depends on the pin, but okay. Later on we will control this one also. So as you can see, the X is the same as the Y, so I will link those. Okay, so now we have a size here that is 2.5 millimeters, and we will duplicate this along this distance. So this distance is here, 20 millimeters on the X. So we can use a divider dividing the size on X with here the size on the X of the patch here. So here we will get a number, actually that's 8, but we should be sure that we have an absolute solution, an absolute value. We cannot get the 8.2. Okay, 1 minute. Wait. Okay, I'm back. Sorry. Difficult to record during the night. Okay. Anyway, so I said okay. So I will control the linear generator for the between. Okay, so we can use an offset number. Not on the Y, but on the X. So here, for example, if I do 2 millimeters or 4 and augment the number, we have the duplication occurring. So we do this way. So if I use this, I can multiply by the number of clone here. So having the offset X connected to the mesh info, so 20 millimeters. And if I check the between, I will have the number of clones in between. But there's no relation with those. Okay, you can get an overlap. So it's not good this way though. So that's because I prefer to didn't use the between solution and use this basic math node that will divide the length by the spacing here and connect this to the count. So if I go there, we have number of clones to 7. Why we have 7? We have a result of 8, but that's not an absolute, maybe that's because. Okay, so here we didn't have 20. We should have 8 every 2.5 millimeters, right? So I should link the Z to the offsets. Yeah. So now we have a square that is duplicated along, and so our pin is following this. So if I change the size of my cube, so the pin count now is not needed anymore. We'll just remove this. Delete user, delete channel. Okay. So now if I change the size of it, you see that it adds. So I need to use a minimum and maximum maybe with this, because you see it can be smaller than the two pins and still it cannot match. Okay, so also I need to offset everything. Okay, so we try this. 20 millimeters, and we should offset this. So now we have this object that have a specific center. Okay, the center is probably here. So I will use an info, a mesh info. Again, connect to this. create another proxy mesh item, add this and use the merge mesh. Okay, this way, merge mesh. Okay, and connect this here. But here we have a mesh info that will give us the position, the offset. So I can use this or just do some mathematics stuff. What's the best way? Probably didn't use the mesh info. We will create too much proxy in between, so that should be better with the math node, doing some maths. The good solution with the mesh info is that every time you do some change to the mesh itself, it will update the dimension. And for the math node, you may need to add some calculation into it if you add some offset. So it's a different solution. I will start with this. So we'll use the multiply. So we will have the cube size that is multiplied by this. So this is the length, okay? You should probably have 20 millimeters, so that's the same as this. Okay, so I will probably use this instead. And here I will divide this by 2. Okay, so now I will... okay, so also the cube is centered. So I need to offset it on the X. So I will use the map node again, divide by 2, use the size Z divide by 2 into the position. That's right. Didn't seems to move at all. Okay, X to the X, of course. Size X divided by 2 into the position. So now we have an offset here, and we just have to reconnect this here, use the position here, and with this, need to select the channel and drag and drop. Okay, now that's working. I say divide by 2, not multiply. So the position should be minus. So I will do -2, divide by -2. So now it's centered. Okay. So now as we change the size, the length of the ship, you see it adds some pins, but they can float. So what I will do, probably to simplify this, is create an offset that is half the distance, okay, of this patch. So this way I can be sure that every pins will match. Can do this way, yes. So should I do this way? Didn't check the chats. You can reply if you have any questions. Don't hesitate. Okay. So, probably add the offsets. So the cube actually is 21, and everything was driving here. So what I will do, probably connect directly the size X here with this here. Seems to work. The video is about to stop sometimes, so okay, so there is some issue with the video. Okay, we'll take a look at this later on. Okay, again, so we have an object here that is duplicated, but a bit too big regarding the size of the cube. So at the source we have this cube that is 21.1 millimeters. Okay, and we are duplicating, creating another object that is 1.4 millimeters bigger. So we can probably use the math in order to change the size of this. So here probably what I can do, okay, so I have some followers, just having some discussion. If you have any questions, don't hesitate. You can feel free to ask. The video is freezing sometimes. Want to know okay, anyway, so what I can do is probably change the size of this and limit to the size of this cube. We're connecting the size X of the cube to that node and divide by the number of the size of this batch. So actually we are, yeah, getting 8.4, so that's why I was talking about the absolute solution. So we can search for absolutes and add this math node here, and so we can use the exponent 1 to get a different output, right? I think that was this. So if I select this, no, that's selling. Okay, the selling is the solution. Or the floor, yeah, so the minimum of, so I have 8.44, so with the floor solution it will get the lower solution, the lower result. So now it should be okay. Oh, that's not. What's going on? we are duplicating 8 times over 2.5 millimeters, so we are bigger. So if I remove one, so I will add a subtract. Now I will be sure that the number of pins didn't go outer of the cube. But of course the position is not good now. Okay, so that's why I prefer to use the mesh info. Yeah. Remember to be lazy. Okay, so we'll go to the mesh info again. The first solution was the good one. Use this, and it will help me to offset everything. So here we have a mesh that will feed into another mesh. So the center will be used. I don't know, merge mesh. Use the merge mesh here, connect to the source, and for the center, we have a center here. It will define the position on the X. So here we have this mesh that is off-centered, is not correctly centered, as you can see with the blue line. So the center on X is this. The value is micrometer. So if I use this, I should use the minus. So I will add a math node again. Basic maths. Connect this here. Multiply by -1. And use this. Okay, so now we have this cube correctly positioned. So now we will not use the first patch that was offsetted, okay, but the new one. So if I show it now, you see it correctly centered. So even if I have a number of 7 or 5 or 3 pins, it will be centered correctly because we are using the mesh center itself. So I will use this new mesh to drive the replicator. Okay. So now if I unhide and show the results, now we will have the replicator here and the original cube correctly centered. Okay, so now just check. As far as I pass a specific amount, it will add new numbers of pins. Okay, so this way you can have total control over the shape of it. So also I was using a multiplier here to define the width and the height in relation with the width. So I will probably add a percentage value. So this will be the height. And so we'll define 0.4, so 40%. Minimum 0. Okay, so I will connect this here. Okay, it looks like it's 4%. Okay, 0.4%. So I will change this to 40%. Okay, so now we have, that's a bit too much. 20 should be better. Okay, so what we have here is correctly the size of the chipset. But probably what should be more interesting is to have the same thing as the first one. If I show it again, yeah, we have some mirrored both direction on the top and the bottom, and it's cut here at the center. So probably what I will do is, even if I use the same cube, I will cut it here. So I will use the segments on the Y. Okay. And with this here, we can start manipulate maybe the shape of it. So I will just left the replicator and the cube just to get more visibility. Of course the pin will be a bit offset inside. We'll take a look at this later on. We were creating the cube with an offset size on the position, so maybe if I remove this, it should be better this way. Okay, we will simplify this. Okay, so remove the channel. Remove node. Okay, so now we are centered. So as we are using just the segments here to define the cut, there's no new edge selection set that we can get back from this, or the select by previous. So I will turn this back to 1, and instead we will use axis slice to slice the cube, okay, with about 2, just one time here, and after we will bevel this one. So now we have one new axis here. And so I will define an edge bevel. And the edge bevel will be derived by a selection. So if I go to select by previous, I don't know if I can get back the... Okay, I couldn't get back the cut of the axis slice. So we will do it in a different way. Not the axis slice we will use, we'll stay with the segments. And with that segment, I will add a new selection, assign selection sets. Change this to edge and say middle cut. Okay, so that's the middle cut. And we will use index, so select by index, and add a selection. So here I go to the edge mode, select those, and set those. So now we are assigning this selection set, middle cut, and we will use it into the edge bevel. I do this because probably I will use this one also in a different stack on the top. So we will use select by selection sets, use the middle cut, and so now we can edge bevel this one. But as you can see, the cube is totally straight. Okay, so we should maybe change the scale with another bevel. So I will use polygon bevel this way. I've probably done this a bit in disorder, but it's okay. I know where I go. So with the polygon bevel, where we will push things out, we'll do this on the top and the bottom also. Sorry. So as it's a cube, I will not do this too much complicated. We'll use just a selection by index, not the currently existing, a new one. and I will select the top and the bottom. Okay, so now with this here, we can not choose the shift, but the inset. Okay, so I can inset inside. I'll probably use this. And I will remove the corner. But the shape set is a bit different. Okay. If I take a look at the original one, should left it visible. Okay, so it's a bit beveled the same amount on both sides. Okay, so on the length and the width, so it's okay. I will do this way. Use a polygon bevel here, and also use delete to remove the surrounding edges that are there. So delete, switch to edge, and of course get a select by previous operation. So now in our case the bevel. So that's the front. Yeah. So not those edge will grow. So if I go, I got this, then I got this. Ah, too much. Okay, so I will do a different way. Maybe add an assign selection sets, because I will select the polygon first, grow the polygon, and use the boundary edges to select those edges to remove. Okay, so we have the polygon bevel here. So this one is used. Here, selection. Oh, sorry, double click. Okay, so we have this one. Then we will use a selection, assign selection sets as polygons this time. So I will call this top, bottom. Okay, copy this, select those nodes and unlink them to the delete. So I will link them to the selection here. So if you want to connect a selection on the top or on the bottom, you see that there's two solutions here. You see on the node, you can put this in at the bottom or on the top, and it's related to this here. So we have the grow on the top, as you can see. Okay, so we are like this. We have a selection in polygon. I can probably do edges. Should try. Okay, so here we are there. If I do a convert. Okay, so if I do a convert, I have all the edges here. And I can maybe add a new selection, boundary. So now we have the boundary section. So we will delete those, right? So here, convert, boundary edges. What's the music here? Okay, I made a... what is... Okay, so that's backspace. So, selection set top bottom. And here, we'll delete those edges by using the select by selection sets. And get back the top bottom. Okay, so as we are doing this, we are here, right? And with that, Oh, okay, so I used the select by index. Of course, the index have not changed with the polygon behavior on top, on the bottom. So that's good. I will stay here and use this to define the edge behavior here. So here we have now a distance that can be changed. Okay. So I have to control this value. I will drag first every node to organize them. Okay, so yes, of course you have in the 13 release just to press the arrow key to align nodes. That's really important to get things organized. So as you can see, we should add also deform folder. Okay, so I'll connect this here, this there. Ah, I have some question on the chat, sorry, I will just read it. Audio reverberation. Okay, accidentally open to instance. You can try to hear me in stereo, but not this way. Okay, 3D polyways. Okay, so I have now this. I should add probably, I have the edge beaver also to connect and show the selection. So we are now with the mesh, with the base. We'll call this the base. And from that, I will add the value of the edge beaver. Okay, so with this value, so the value here of the edge beaver, and also the size here, or I can say the cube itself is at this size. So if I go to the right side view, we are at about 2 square, okay? And if I go to the top of the procedural work, you see that the size is didn't changing here. So the edge beaver probably is a percentage of this distance. So I will do this way, and now I will not do the wrong things. So maybe just let's say we'll use a percentage also for the middle cut. So middle beaver, middle cut. Well, we'll use beaver. We'll do some more cuts after on. So here I will define about 30%. So the maximum will not be about 80. Yeah, the maximum will be 80%. I will not go further than this, probably. So okay, do this and connect that to the value here. So we'll add basic math. Hop, connect this here, change this to multiply, connect this to the edge value, right? So of course we have 0 at the moment, but I will use the height, so directly the size here. So now, as we can see, we have a middle bevel that is controlled here. So if I go to 50%, it's the maximum. Okay, so I couldn't use probably this. I will just edit the maximum and will not go further. But it's a bit weird because we are talking about 50%. and 50% is the maximum. So I will use a divider instead here, so divide by 2. Not this way, it's a multiple divide. Which is the basic math. So math, basic math, divide by 2. Here, reconnect. Okay, so now that's better. And if I go to the maximum, so I said 80%, yeah, that should be okay. 80% the maximum. So it make more sense to have about 80% of the height here and 10% this way. Okay, so that's fine. And as you can see with this, what is interesting is with the mesh info, the size is automatically updated, so the pin is always stitching to it. See, it goes inside. Okay, so we are good. It was a bit messy at the start, but now it's okay. Okay, so we have this. What we can do probably is adding this cut here with a Boolean. So we go like this to 20%. Should look like same. Make this a bit smaller. Oops. Yeah, as the height is a percentage of the width, maybe it's not a good solution, because if I change the width, I change the height also, you can see. Okay, so I will change this. So we were using the multiplier for the height, so we'll not do this way. We'll kill this one and remove this height as a percentage. So delete channel, and we'll use height again, but this time with distance. And we'll say, okay, 2 millimeters. It's about this size. Okay, so remove the maximum and reconnect. So now the different connections are crossing each other. Okay, so you can reorganize things, but I will probably save the scene first. It's always important to try to do this if you have any issue after all. Didn't lost anything. So maybe hide this one. And here under the channels, you can reorganize the user channel we've created. So what I will do is select my assembly, select the height, and move this up. So yeah, that's more logic. We have the length, we have the width, we have the height, and after we have the middle bevel, that is a percentage. We can also add a divider. So I will do this way here, clicking on the plus, and we'll call this just detail at the start. Whoops, sorry. Okay, so detail properties, we'll call that a bit different later on, just to make a divider. So a divider here is this, same as this line. Okay, we have divider everywhere in the UI in Modo. So those can be used to organize your layout. So here we are selecting the display, the detail properties, and move this up. And as you can see, now we have a divider that we can collapse also. So that's really powerful. There's a bit of delay between what I'm doing and what you see. Please tell me if there's too much latency. Oh, sorry, I'm pressing the keyboard a bit too loud, and also in the wrong QWERTY configuration. Okay, so I will. Is there too much latency? If I press, okay, I will add did you understand if there's some latency between what I do and what you see and what you hear? You can tell me. Oh, strange music. Welcome to the wonderful land of mashups. Okay, that's funny. So, what I should do... So, I was talking about doing the cut here. So now we are maybe probably testing this first. We have the inputs, we can change the length, the width, and we'll go back to the normal shape, and the height. And also here, the size of the cut. And also I forgot, but I can control the taper effect here, right? It's in the polygon bevel that we've used before. So if we change the inset, oh, I didn't show the end result. If we change the inset here, we can change much more the shape. So as you can see, of course, the inset should be maximized to this size, okay, the width probably. So it's 1.5 millimeters. Maybe what we have? We have a mesh actually that is. I'll show the dimension. That is 4 millimeters size for the width. So we'll check this and go back to 4 totally. What is strange is, okay, of course, I do the bevel. So if, as I do the edge bevel, it cut out the shape here. So the result we have here is not the same as what we are searching for here. Okay, we have 4 millimeters, but with the edge bevel, we have a different size here, right? So later on, we will use this another proxy to get back this value, okay, in order to maximize the polygon bevel inset. So anyway, I will put the inset into the schematic. So I should control this also. That will be a new channel into the detail properties. So taper, we'll call this taper. Taper size, taper amount. Oh, just taper. Okay, simplify this. Distance. Then we will use this minus 0.5 millimeters. That's too big. 5 millimeters, 0.5 millimeters should be better. Okay. So now, as we are here, we can, control this. But the maximum should be in relation with this. So, of course, this chipset is maybe from a different generation of Intel computing, maybe in 2 centuries. Okay, so we will change this back. 1 millimeter is too big, 0.5, and create a new mesh. I will add this here. I will regroup everything after on, but everything is at the root of the scene, so there's no hierarchy that can mess up everything here. Okay, so we'll use again a merge mesh. And really the merge mesh is like what you can find in After Effects when you pre-compose your composition. It's like the same stuff, really. So I will put this here on the top, and I will probably add a mesh info also, and the mesh info will get the information there and helps us to get the value. Okay, so here we have now the value maximum on the Z is 3.7 millimeters. So what I can do is maybe select this. We have 3 millimeters here and the value here. So with about 3 millimeters, oh, I can do this more quicker with a mirror. So cutting on the top and mirror. Don't know. Okay, we'll do this later on. We'll put this on the side. I will paint these two different color, white, just yellow because that's temporary, and concentrate on this one. Okay, so we'll do the cut, so probably use this instead. Use a Boolean, so we'll merge this one, so we'll hide this here. Now we have a new mesh here, and we will create another mesh for the container of the cylinder. So cylinder. And with the cylinder, of course, that might be too big cylinder for sure. So we'll see, we are on the y-axis, so the x and the z should be connected. So this way I can just change the radius here. So if I do 1 millimeter, that may be too high. Okay, so this one is better. For the radius on the y, it should be probably the same as the radius y. And now we have something not at the good position. So, okay, I should offset this to the edge here, right? So what we will do is to get always this mesh, the cylinder, always connected. I mean, at the center of this edge here. We can do this in different ways, but probably the best way is to get the face at the top here, and only this one via some delete operation, and this way we can probably get the size, so the position can be defined. So again, another mesh item here that will get the chipsets. So we'll use this one, the first one. Oops, I need to add a merge mesh. Okay, so the merge mesh connected here. And now I will probably remove and get just the top part of it. So to do this, I will use a delete. So add a delete. Change this to polygon. And in the selection, I will use select by normal. So you can use this this trick, or you can use, okay, so I will show you the twice. You can use the normal of an object that is at a specific position. So if I'm using a locator, I'll create a locator here. If I use this locator to drive the selection of the normal, I should add the work position and connect it to the position here. So if I show the selection, delete and move the locator, do I have the move tool? No, I didn't. Okay, so if I move the locator here, and we are in the final visibility of this mesh, you see that the delete is happening on the top, because the normal is looking to this, I mean the normal of this polygon here is pointing into this locator. So if I move, of course, this one, I will remove the side one, or further lower the side. Okay, so you can delete dynamically stuff into the mesh. So this is using the select by normal. So in our case, we need to define that the maximum angle is about 2. It's a bit too much. And maybe, okay, no, that's okay. I will stay with 2 degrees, but I will move the locator much more up. So we will move this by 1 meter, and the locator is there, still at 1 meter on the top, and so the only one faces that is deleted is this one. So if I want to delete the rest, I just invert. And now I have just the top part of it. Okay, this is one solution where you can use the select by normal. The second solution to do this is not using a locator, but using a matrix. Yeah, good reference. Matrix construct. And the matrix construct is just creating a matrix that is the same as the work position here. You see that you have a matrix of 3 by 3 square point. So with the input on the x, y, z, and with the matrix type to position, you can define that, okay, I will use 2 meter or anything and connect this here. So now if I did the locator, I can just use the matrix construct, and it didn't create a locator visible into the scene. I prefer to do this, but it's up to you. It's more lighter to do this way. But yeah, you can do this way. So as we have this face at the top now, we can get the size of it. So with the info again, that's probably the mesh op rig where I'm using the most the mesh info. Okay, so we've talked that the cylinder is here, so we will call this cylinder cut sub, because we will use this as a subtraction, and for the Boolean, and this one will be top face. Oops, top face. We'll call the base top face, because the base were the first mesh here, right? So base chipset, maybe we'll call this a bit better. It should be a mess after all. Base chipsets, I will put this at the front. Okay, chipset base, and here we have the chipset base top face. Base top face. Okay, so now that we have this, we can get the maximum. So we will say that the marker of the chipset will be at the positive or the minimum, the minimum X position. So like right here. Okay. So here we have the correct cylinder subtract. So this mesh should be derived. So we will use the position X, the Y, not the Z, because we will stay with the centered marker. So we just have to use the mesh info here. It is using the minimum X as the position. So now, oops, I do some mistake. Okay, get back. So now the cylinder is derived on the X. And also I should drive it on the Y axis. So I will use this. And now you can see it's automatically positioned correctly. Okay, if I reconnect stuff. Okay, so now if I select my assembly and change the length, you see that the cylinder is following. So with that, we can create the Boolean result of this. We'll remove that. Okay, so we will organize a bit more the setup. What the music is that? Yeah, I know, that's just free. Hi, Emmanuel. Thanks for watching. You can use the Discord also. I didn't talk about this, but I can hear the sound if you are speaking on the Discord. Should work. I didn't link the. Okay, I will add the link directly into the chat. So you can join on the Discord. If you want to speak, that could be better. This way you can participate and ask anything. I have some music that is really strange for this stream, sorry. We'll switch into another one. Okay, that's finer. Okay, so I will reorganize stuff a bit. So we have the base here. I will probably move this on the top and change the color. So I have a special tool for this. If I remember correctly, the Control Alt F1, no, Alt F1, Control F1. Where is my little menu? I have a menu especially for this. Should find it. Okay, open like the SMOLUCK kit, game content kit, SMOLUCK color. It's attached to a key. What is the key for that? Shift F1. Okay. So Shift F1. Yeah. Okay, that's better. So we will group those. So we have the base here. That will be the start red. Then here we are duplicating this to create the Boolean. So we will hide this one. This is just the start. Okay, so it's hidden already. I will use the mesh here. and add a Boolean. I'll save incremental. So add Boolean. And the driver will be the cylinder, but I didn't name it already, so I will stay here, say OK, organize the Boolean, and maybe move the cylinder. So that was the top part, and this is the cylinder. Okay, so I will organize this like that. So the backdrops, that's a good, very good implementation to the schematic. Organizing stuff is a mess, and with the backdrops, that's much better. Okay, so here we are with the cylinder. Oh, it was named. Okay. So the driver will be this. And so now we have a new mesh that is cut out here with the cylinder. So probably the cylinder should be a bit less sided. So maybe say 16 should be fine enough. Okay, so now we have a result with this, with that. Okay, so maybe also use a backdrop here, change this to color brown, and this will be chipset base Boolean, or composite, I will say. No, composite is for the final one. Boolean result. Okay, so now we have this, and we have also the composite here. So the composite should merge also the case. So I will add a new merge here. Merge mesh. And this merge mesh will get connected to this one. Okay, so I will connect it right here. Source, yeah. So now, if I hide everything, we have the starting point. So now we can first save the scene. Don't be afraid to save, that's important. So we have an assembly that can hide the grid, that can change the length. Okay, so we are changing the length like this, and also the width. Of course, the size of the marker should be a percentage of the width, probably. And the middle bevel is also there, so I can change the shape here. Oh, the Boolean is working perfectly, it's fine. So we can change also this to make a much more sci-fi chipset. Okay, that's cool. It's okay, it's fine. So we have this. Probably I should maximize the size of the, get a minimum for the size of the bevel in order to be sure that this is totally plain and not smaller. So if I change the size to, so let's say 30%, you see that, yeah, it's not connecting correctly, so I should use a specific size for that. So let's say 60, okay, 60 will fit better. And of course the taper is too big, so I go back to this. Okay, so now that we have this, we should organize that. So this one is the composite, the chipset composite. I should probably make the different pin at the end, at both sides of the chipset, because as you can see in the reference, where is the reference? Okay, and yes, oh, it's not there. It was not there. Where is the pin prototype? Where is the preference? Okay, so as you can see, the pin at the end is a bit different. It's a cut in middle and maybe a little offset. So I will do this maybe on the next video. Okay, so just to check, we should make a test with the composite. We'll save the scene, and what we will do is go to the animation. So I will go back to the model layout, it should be better, show the time and the graph. Okay, so that's a bit crappy, I will organize this later on. Okay, I will hide the rest. And we have the chipset. So the chipset also position is not good. I should offset it to get syncs, maybe here for the center. But anyway, just to make a test, and because the time is going on, I will just do a little test. So we have the assembly here. With this assembly, I can animate properties in the assembly channel. So we will start with a length of 8 mm. Okay, so 8 mm with 4, and height is too big, maybe 2, 3. 1. Okay, 1, and the taper is too big. I'll go this type. Okay, so here we have the first chipset, right? So I will key those. And at the frame, we will do just 10 different version release variation of this. So I can go to 9, maybe change the length. So we've gone from 8 to about 10 mm more, so I will do this. Maybe a bit more, 28. We'll go 28. Okay, so 28. And so now we are just animating the mashup, right? So we have a variation like this for the length, but also we should do this for maybe, so here we are at 9, so we are after 10 version, so I will go here, and do another key, but on the width this time, and on this one I will augment it to 8 mm. Okay, so as you can see, during the time it's growing. Maybe I should change this to linear or stepped, yeah, stepped for the width. So I will make this repeat, not after all, constant smooth, and repeat for the rest of it. And that's not smooth flat that I want, but stepped. Okay, so here we are here, and we have this amount. So you can use math also here in Modo to go to the next step. So here I will press again 4 and goes to 8 mm. So what we will have here is a change on the length, and also the length will be repeated over time. So I should check this linear for this one and repeat. So as we are playing the animation, it grows, then it will change the width and be different this way. Okay, so maybe that. Okay, so after that, offset. Ah, yes, I should offset. Okay, so we have the width here that is coming from 4 millimeters to 8, and then it goes back. So we should offset this. So repeat, but offset. Okay, so I will remove maybe this key. So now if I get a bigger view, you see that it will grow in width till 40 millimeters. So this way you can make many different elements with the same setup over time. Okay, so it's working. Just for the purpose, I will do a little test and export those as an FBX, just to check if everything is going on. So save the scene. Where is my... Oh, okay, so in the Mesh Fusion tool, Open Mesh Fusion tool, I will check this. So I have the mesh selected. I should define the start and ending frame. So we'll do just the test on 18 frame. So we got 19 in total. So if I go here and goes to export mashup rig sequence 2, I can export it to FBX. So the actual animation will be retained at every frame. So I will export this as directly triangulate stuff. So I will save that into the temp folder. Where is that? Temp, blah blah, test, open it, and export. So this will be the chipset. Twitch. Okay, I press OK, and I have no UVs for this, so I have no tangent basis exports. Okay, so I need to select it. Right. So I will do this again. Even if the texture is not good, we will do this in Rizom later on. Okay, so I'll do this again. So that was chipset, sorry, chipsets, Twitch. Press OK, and now we will have Modo running time after time and exporting all the different elements. Okay, it's finished. So if I go back to my analysis, you see it exports the mesh 1, mesh 2, mesh 3. It's about the frame. Okay, so mesh at frame 0, mesh at frame 1, etc. So it's running. Okay, so I will save the scene and load all the elements that I've exported. So close scene, and here I will load them. Where is that? That's load FBX sequence as array. So here now I go back to the temp folder. It was this one. I select all my FBX. I have a name here that I should copy first. and then paste into the pop-up window. Okay, it's fine. The pop-up window is there. It's a bit long. Don't know why, but anyway. So I have a strange error here, but it looks like I have to drag and drop the target back into the group. So what I will do is selecting all of them and move them into the group. Okay, the group is empty. There is some issue with here with this. I'll show the group. So groups are on the side. Okay, so now I have to select all of those. I can select them directly by item type, probably, I hope, but that's imported reference, so I don't know if I can do this. No, I couldn't. Okay, so I will select those here. Should check what is going on with this on the script. Anyway, we'll move them to the group. And now, if I only display the replicator, so I will only show them. They are all here. Okay, they are a bit bigger. A bit small for the replicator setup. So I will go to the group, select the array target, and now I will change this to 2D. We have this amount of elements, and we will use 10 millimeters, maybe not 20, okay, 20 millimeters for everyone. Not on the Y, but on the Z. So now if I check my replicator, I have all the different chipset that I've exported. So this is just for reviewing all the different exported elements and check if everything is okay. Well, yeah, that's just a basic export. So if I check the replicator, we probably have some what is that here in the replicators? Can have some random rotations. Okay, so I have some random rotation by default. So of course you can get them like this if you wish, and get still the control over the offsets. So I can extend them and pack them if I want to, without overlap. Okay. So yeah, that's all. Now I have plenty of different elements with just a few minutes. Yes, I took about 1 hour and a half, and it takes time to create this, but I was starting from scratch and without any preparation at all, just exploring different possibilities. So now, of course, I can randomize maybe the subtract effect here, randomize maybe the prototype that is used for the pin. There's plenty of work that you can do here with this. So yeah, I hope you enjoyed the video. I will finish this one. Thanks for coming this time, and I will contact you later on. So please put your name in the chat. I will have some probably little gift for you if you are using Modo or RizomUV. So let me know in the chat. I will probably give you some interesting gifts that need you to be interested into RizomUV and deploying the UVs. Sounds fancy, yes? Yeah, use UDIM in Rizom. Yeah, I know, Emmanuel. I will try to make one. I'm actually learning it. I will try to make one. Yeah, UDIM workflow. I'm not really using UDIM workflow because I use usually standard UVs for Unity. But yeah, that should be interesting, and I will probably do this later on. So see you, and thanks for your support, and come back to the Twitch as you wanted anytime, and you may also have access to the Discord. So I remember, yeah, you can see it here. You have the Discord at the bottom side. You have all the information. See you next time, and hope you like the video and subscribe. Bye bye.
Yum, yum!